So those are all the properties of TLS. It's a quick tour of all those properties. Now let's think about how TLS is actually used. So we've already said that TLS lives between layers 4 and 7. Think of it like layer 4.5. And this means that users at layer 7 are allowed to use TLS as a building block. So for example, if you're using HTTP, a layer 7 protocol, you can run over TLS. And the resulting protocol is called HTTPS, where the S stands for secure. That's still HTTP. It still uses the same get and post methods. It just runs over TLS to encrypt everything instead of plain HTTP, which runs over plain TCP with no TLS. There's also other layer 7 protocols that can use TLS. So for example, if you're playing some online game and it uses some layer 7 protocol, that could also run over TLS. If you're using SSH to log into a remote server, that can also use TLS. So other application layer protocols also exist. That being said, it's important to note that TLS doesn't stop layer 7 attacks. So remember all of those layer 7 attacks we talked about during the web unit, like SQL injection and XSS and CSRF? TLS doesn't stop those. Why is that? Because even if our messages are fully encrypted when they're sent across the network, if I'm talking to a malicious server, the malicious server could still be vulnerable to these attacks. So for example, if I'm the attacker and I send a malicious SQL query to a server, TLS just encrypts the malicious query. But once the server receives it, they still decrypt the malicious query, shove it into their SQL query, and now we're running SQL queries on that remote server. So this doesn't stop any of those layer 7 protocols. It just encrypts messages sent across the network. But if you're sending malicious data across the network and you're talking to another server, that server could still be vulnerable to all of these attacks. And likewise, if a malicious server sends you malicious JavaScript, your browser is still going to run that JavaScript. Encrypting it over the network doesn't solve that problem. So more about how TLS is used in real life. There is an attack that attackers might try. It's called the downgrade attack. And basically, the idea is to force someone to downgrade from using HTTPS to using unencrypted HTTP. So we will not go through all the details. But basically, the idea is that if a user tries to contact a server using plain HTTP, sometimes the server will force the user to use HTTPS instead. So the server would reply saying, I don't support HTTP. It's not secure. You need to use HTTPS with TLS instead. However, because that initial request and the server's initial response that says use HTTPS instead, because all of that is sent over unencrypted HTTP, a man in the middle could actually intercept that HTTP response that says, please switch. They could drop that packet and then cause the user to use unencrypted HTTP. And now the user is no longer secure. So this is called the downgrade attack. You don't have to know all the specific details. But at a high level, the attacker is causing the user and the server to use a less secure protocol at the start.